Hey there, space explorers! Welcome to an incredible journey through time and space. Today, we're diving into one of the most fascinating aspects of our universe. Have you ever wondered what the universe looked like when it was just a baby? Imagine the cosmos as a newborn, full of potential and mystery. It's hard to imagine, right? The vastness of space, the countless stars and galaxies all had a beginning. But what did it look like back then? We're talking billions of years ago. To be precise, about 13.8 billion years ago. That's when the universe was in its infancy, just moments after the Big Bang. Lucky for us, the universe left a little something behind. A snapshot, if you will, of its earliest moments. It's like a baby picture. But instead of a cute photo, it's a cosmic relic that scientists can study. We call it the cosmic microwave background. This ancient light is a treasure trove of information. That's a mouthful, so we call it the CMB for short. The CMB is like a time capsule, carrying secrets from the dawn of the universe. The CMB is like a secret message from the early universe. It holds clues about how everything we see today came to be. It's been traveling through space for a very long time. Imagine light that has been journeying for nearly 14 billion years to reach us. And guess what? It finally reached Earth. This ancient light is like a cosmic messenger, bringing us stories from the universe's infancy. Scientists can study the CMB. By analyzing this faint glow, they can learn about the universe's first moments, its composition, and even its future. It tells us about the universe's first moments. How cool is that? So next time you look up at the night sky, remember, you're gazing at a universe with a rich and ancient history, one that began with a brilliant flash of light. Okay, so how did the CMB form? Well, picture the biggest explosion ever. We call it the Big Bang. It's how the universe began. The Big Bang was super hot, like unbelievably hot. As the universe expanded, it cooled down. But guess what? Some of that heat is still around today. That leftover heat is the CMB. It's everywhere in space. You can't see it with your eyes, though. It's not like the heat from the sun. The CMB is a different kind of heat. It's called microwave radiation. Don't worry, it's totally harmless. Remember old TVs? The ones with antennas? Sometimes they showed static, that fuzzy gray stuff on the screen. Well, guess what? A tiny bit of that static was actually from the CMB. It was like a secret message from the beginning of time, hiding in plain sight. Scientists figured out that the static wasn't just random noise. It had a special pattern, and that pattern matched what they expected to see from the CMB. It was a huge discovery. It proved that the CMB was real. Think of the Big Bang as a giant bell being rung. The sound of the bell would travel far and wide, right? The CMB is like the echo of that bell, but instead of sound, it's made of light. It's the faintest whisper of that incredible event that happened billions of years ago. The CMB tells us that the early universe was incredibly hot and dense. It also tells us that the universe has been expanding ever since the Big Bang. That's right, the universe is getting bigger all the time, and the CMB is our proof. Section 5 Telescopes, Our Eyes on the Past. Scientists use special telescopes to study the CMB. These telescopes are super powerful. They can detect the faintest signals from space. It's like having super-powered eyes that can see back in time. One famous CMB telescope is called Planck. It's named after a famous scientist named Max Planck. Planck took amazing pictures of the CMB. These pictures help scientists learn even more about the early universe. Section 6. Hot and cold spots in space. Have you ever wondered about the mysteries of the universe? One of the most fascinating aspects is the cosmic microwave background, or CMB for short. This is the afterglow of the Big Bang, a faint light that fills the universe and gives us clues about its early days. The CMB isn't perfectly smooth. When we look at it closely, we can see that it has tiny differences in temperature. These variations are incredibly subtle, but they hold a wealth of information about the universe's infancy. It has tiny differences in temperature. Some parts are a little bit hotter, and some parts are a little bit colder. These temperature differences are only a few millionths of a degree, but they are crucial for understanding the cosmos. Some parts are a little bit hotter, and some parts are a little bit colder. These hot and cold spots are not random. They tell a story about the early universe, and some parts are a little bit colder. These differences are incredibly small, but they're important. They represent the tiny clumps of matter that existed in the early universe. These differences are incredibly small, but they're important. These hot and cold spots tell us about the tiny clumps of matter that existed in the early universe. These clumps were like seeds, the building blocks of everything we see today. These hot and cold spots tell us about the tiny clumps of matter that existed in the early universe. These clumps were like seeds. Just as seeds grow into plants, these tiny clumps grew over billions of years. These clumps were like seeds. Over billions of years, they grew into the galaxies we see today. Imagine that. Tiny fluctuations in temperature leading to the formation of stars, planets, and entire galaxies. Over billions of years, they grew into the galaxies we see today. The next time you look up at the stars, remember that they started as tiny fluctuations in the CMB. It's a humbling thought, isn't it? So, the next time you look up at the stars, think about the incredible journey that began with tiny temperature differences in the CMB. These small variations have shaped the universe in ways we are still discovering. Remember that they started as tiny fluctuations in the CMB. The universe is full of wonders, and the CMB is one of the most fascinating clues we have to understand its origins. So keep looking up and keep wondering. Section 7. Dark matter and the expanding universe. The CMB also provides evidence for some pretty mysterious things. Things like dark matter and dark energy. Don't let the name scare you. Dark matter is like invisible glue that holds galaxies together. And dark energy is like a mysterious force that's making the universe expand faster and faster. Scientists are still trying to figure out exactly what dark matter and dark energy are, but the CMB gives them important clues. It's like a cosmic puzzle, and the CMB is a big piece of that puzzle. Section 8. Keep exploring the cosmos. So, there you have it. We've journeyed through the vast expanse of space, uncovering the secrets of the universe. From the birth of stars to the mysteries of black holes, our exploration has only just begun. The cosmic microwave background is a fascinating relic from the early universe. It's a baby picture, a leftover echo, and a cosmic treasure trove of information all rolled into one. This ancient light has traveled billions of years to reach us, carrying with it the story of the universe's infancy. It tells us about the Big Bang, the moment when everything we know began. This explosion set the stage for the formation of galaxies, stars, and planets. The cosmic microwave background is like a time capsule, giving us a glimpse into the universe's earliest moments. It tells us about the Big Bang, the expansion of the universe, and the seeds of galaxies. These seeds, tiny fluctuations in the early universe, grew into the vast cosmic structures we see today. Understanding these processes helps us piece together the puzzle of our cosmic origins. The expansion of the universe is a phenomenon that continues to this day. Galaxies are moving away from each other, and the universe is getting larger. This discovery has profound implications for our understanding of the cosmos and its ultimate fate. And the seeds of galaxies, those tiny fluctuations, are the building blocks of everything we see in the night sky. From the majestic spiral arms of the Milky Way to the distant faint galaxies at the edge of the observable universe, these seeds have grown into a breathtaking cosmic tapestry. The universe is full of amazing mysteries waiting to be uncovered. So keep asking questions, keep exploring, and never stop being curious about the vast and wonderful cosmos we live in. Every question we ask, every observation we make, brings us one step closer to understanding the universe's grand design. Who knows what incredible discoveries await us in the future? Perhaps we'll find new planets, uncover the secrets of dark matter, or even discover signs of life beyond Earth. The possibilities are endless, and the journey is just as important as the destination. So grab your telescope, look up at the night sky, and let your imagination soar. The The cosmos is a vast and wondrous place, and there's always something new to discover. Keep exploring, keep dreaming, and who knows what wonders you'll uncover next.